Okay, welcome to the lesson on integer exponents. So we're starting this small unit on exponent laws, and we're just looking at basically 3 lessons and then a small quiz to evaluate you on it. So we're looking at the first unit. Like, a lot of you guys will know what exponents are, what they do. We've talked about that. But we want to talk about integer exponents. And so that's going to require 2 things that we maybe don't know so much about. And that's going to be the exponent 0 and the exponent and the negative exponents. And so we're going to just talk about exponents in general and look at what an exponent is first. And so for a warm-up, we want to ask how many 2's are being multiplied together in the final answer. This is going to be one of the skills that you're going to need to know how to do is to simplify something like this without a calculator. And so we want you to don't actually want you to sit there and multiply this, but I want you to count how many 2's there are. And so if you look at this, you can see there's actually 5 2's here, and there's 6 2's here. So 5 2's are multiplied together, and 6 2's are multiplied together. And so this gives us 11 2's on top. And 4 2's are on the bottom. If we just wrote these as a whole bunch of 2's and divided out 4, that you can see there's actually 7 2's multiplied together. So 5 and 6. And then take away 4 of them. Here you've got, if 64 is 6, 128 is actually 7 2's. So you have 7 2's here and 1 more 2. That's 8 2's, and take away 5 2's on the bottom, there's actually 3. And so I want to kind of recall what is an exponent. So it's maybe been a while since we've talked about what an actual exponent is. And so remember that it's actually repeated multiplication. So when you say there's 2 to the power 7 or 2 to the power 3, that's 2 times 2 times 2, 7 times. The 2 is referred to as the base, the 7 is referred to as the exponent, and the entire thing, both base and the exponent together, make up a power. So we're going to look at a chart here to kind of talk about what the exponent 0, what exponent negative 1, negative 2, negative 3 do. And so we know these ones already, so it's going to be something similar to this. This one you probably don't have to remember exactly. Like, we can actually use the powers of 2 to do this, but everything else should be fair game. 4 to the power 3 is 64, maybe is difficult. 3 to the power 4 is 81, is maybe a bit difficult. So those are all the ones you have to know. And I'd ask you to know all the powers of 2. It just gives us more ammunition to do questions. And like the one we just saw before. So the question is, like, what happens if you have 2 to the power 0 or 2 to the power negative 1? The pattern here is multiplying by 2, and so we can guess that the pattern going the other way is actually dividing by 2. 2 to the power 0 is no 2's multiplied together, but you are multiplying, and if you don't multiply anything, you actually have 1. And 1 actually completes this pattern. If you divide 2 by 2, or 3 by 3, or 4 by 4, you actually get 1. And 2 to the negative 1 is not a negative number, it's a fraction. Negative 1 becomes divide by 2 again, so we got 1 2 on the bottom. Divide by 2 again, we get 1/4. Divide by 2, we get 1/8. And then 3's and 4's are similar. You can see this pattern that, like, if you go this way, really 2 to the power 3 is the same as 2 to the power negative 3. It's just a fraction, 1/8. Or 2 to the negative 3 is just the same as 2 to the 3. It's just a fraction. So one way, if we go one way, we're actually multiplying by the base, 2 or 3 or 4. And if we go the other way, we're dividing by the base, 2, 3, or 4. In general, anything to the power 0 is actually an exponent 1. The only case that we don't get this is if we do 0 to the power 0. You got a whole bunch of people saying 0 to the power 0 is 1, but you say, like, well, 0 to anything is 0. So the case here we say is undefined if x equals 0. So x cannot equal 0 here. A negative exponent is just the reciprocal of the positive exponent. And so we actually get this kind of slide idea that we're going to end up doing, where we take a negative exponent, we just slide it down to the bottom and make it a positive. Some of the exponent rules, like, we're going to use these rules, but, like, we want to make sure we understand them. If you had 3 to the power 4 times 3 to the power 6, what you're basically saying is 4 3s and 6 3s. And so we've got 10 3s together. And so the rule here is add the exponents. If you had 3 to the power 7 divided by 3 to the power 3, you'd have 7 3s on the top, 3 3s on the bottom. And the 3's cancel out, all but 4 of them on the top. So we get 3 to the 4. And so the rule there is 7 minus 3 is actually 3 to the power 4. And the last one, if you have power to the power, throw a 2 in here. 2x cubed to the power 4. But remember that as 2x cubed, 2x cubed, 2x cubed, 2x cubed. And so how many 2's you have, like is 4 of them, you've got 12 x's. 3 x's here in each one. So there's 12 x's. So the answer is 16x to the power of 12. Okay. Notice we've got, when we raise 4 to the 2, we're actually using the exponent. This is almost like 2 to the 1 times 4. And this is x to the 3 times 4. This is multiplication. Some examples we can walk through. For the first one, we can see that there's 3 to the power 3 on top. So we can subtract or add the exponents to the numerator, and then do the exponents to exponent rule. And then what happens is we can subtract the exponents. 3 minus 6 is negative 3. And then we can slide that thing to the bottom just to simplify it and discuss how we've got actually 1 over 3 to the power 3, which is 1 over 27. For the second one, we can bring the negative 4 in. You can also flip the fraction here. We'll see that in a second. 2 to the power negative 4, 3 to the power negative 4. We slide the negative exponents. If they're in the denominator, we slide them to the numerator. And if they're in the numerator, we slide them to the denominator. It makes them positive exponents. Make them easier to deal with. You can flip this originally and write 3 over 2 and then bring the 4 in. And you can see how that would be the same thing. So 3 to the 4 is 81 and 2 to the 4 is 16. Here you get a question where you kind of want to put the 4 and the 2 together, but they're not the same base. So we can make them the same base. And so you ask yourself, what would be the same base that would make them the same? And so if they're both powers of 2, we can write 4 as 2 to the 2. We can then use our exponent law, 2 to the negative 14. And we can put those together and get 2 to the negative 5. Lastly, we slide the 2 to the negative 5 down. And we say the answer is 1 over 32. We always want to deal with things in positive exponents, so we always end up sliding that down. Or sliding it up if it was a negative in the denominator. The next one's similar to that, but you ask yourself, to put these together, what can we make them all equal to? And so they're all actually powers of 2. So we could say 8 is 2 to the 3, 4 is 2 to the 2, and 16 is 2 to the 4. We can use our power to the power rule to get the exponents together. We count 14 2's on the top, 12 on the bottom. And so all but 2 cancel out on the top. And we don't have to write the denominator if there's no if the denominator is just 1. And so we get an answer 4. A lot easier to evaluate than what we had originally. So that concludes our examples here. Just want to look at a common mistake that we see. If you had negative 2, so this is actually dealing with a negative base. We have to kind of know what to do with the negative base. And so if the negative base, we can actually just, it depends on what exponent we have here, but if we have an even exponent, it's going to be a positive number. And if we have an odd exponent, it's going to be a negative number. But you got to be careful, because sometimes you got to know, look at the brackets. If it's a negative base, you'll have brackets to an exponent. This second one, you don't actually have brackets. So the difference between is the negative 2 is negative 2 times negative 2, which becomes a positive 4. And the other one is a negative 2 times 2. It's just the 2 that's squared, and the negative is left alone. And so it's a negative 4. Okay? And so there's some practice questions for those.